Hi all, so this is my second time recording this video because the first one, for some reason, the sound isn't working. I apologize for that. That is really, really strange. But, so these are going to be shortened explanations because I'm trying to get this done quickly so I can get it out to you guys so that you have time to look at it. So in the first one, it says that triangle ABC, let me just highlight triangle ABC, is congruent to triangle DCB. So if we know that triangles are congruent, we know that their corresponding parts, their corresponding sides and angles are also congruent. So I'm looking for the answer choice that correctly puts the corresponding parts together. In answer choice 1, AC does not correspond to BC. They're not in the same spot. CD does not correspond to AD. CDE, BAD. BAD is outside of that triangle. It does not correspond to CDE. BAC corresponds to CDE, and that is the last answer choice here. Okay, moving on. Vertical angles. For alternate interior angles, the lines do need to be parallel. So the only one that on its own is enough to justify angles are congruent is vertical angles. Intersecting lines always form congruent vertical angles. Okay, the correct answer here is A, and the reason for that is this is SSA. In your explanation, you can just say SSA is not a valid method of proving triangles congruent. The other ones are valid because here we have AAS, here we have HL in these right triangles, and here we have ASA. Moving along. If you do not draw a picture for this one, it is absolutely impossible. So here is ABC, and here is A prime, B prime, C prime. So in the first one, AB is congruent to A prime, B prime. BC is congruent to B prime, C prime. And angle A is congruent to angle A prime. This is not valid. This is SSA. No, that does not work. Let's reset. Oops. Okay. Let me reset here, and I'll try out the next answer choice. AB is congruent to A prime, B prime. Angle A congruent to angle A prime. Angle C congruent to angle C prime. This does work. This is angle, angle, side. Already I see answer choice number 3 would not be valid because that's only angles. So that's AAA, which is not one of our 5 methods. And then finally, if you try out answer choice 4, it should once again be SSA. Okay, moving along here, we know that AB is parallel to CD. I'm going to stop right there. I have parallel lines cut by a transversal. So I have congruent alternate interior angles. I also have this shared side that's congruent to itself by the reflexive property. And in the givens, it also tells us that angle ABC is congruent to angle CDA. So we have AAS to prove the triangle's congruent. Angle, angle, side, angle, angle, side. Okay, moving along here. So Kelly knows that angle A is congruent to angle EDF and has already proven AB congruent to DE. So it's saying which one would not prove the triangle's congruent. So answer choice 1, AC and DF. Well, that does work. That is side, angle, side, angle, side. So that would prove the triangle congruent. That's not the choice we're looking for. We're looking for the one that does not. Okay, next one, BC, congruent to EF. Well, that's not SAS, that's SSA. So we found the answer choice that we are looking for. The other choices, if you try them out, should be what they say. This one should give you AAS, and this one should give you ASA, which are valid. Okay, we know that AB and AC are congruent, and since DB and EC are both a third of those whole segments, they should be congruent as well. You can think of it like if both of these are 12, and these are both 1/3 of 12, well, these are both 4, so they're congruent. If you take a third of congruent amounts, you end up with congruent amounts as well. I'm just highlighting my overlapping triangles in 2 different colors. And I'm also going to really, really quickly just draw them separately over here. This is DBC. This is ECB. And we already said that these sides are congruent. And in our givens, they tell us, well, we already used that AB is congruent to AC, but I see also that there is a shared side, BC, between the two triangles. So I'm going to put that here. And then also in the big triangle, since we know that AB is congruent to AC, we know that triangle ABC has two equal sides. And if a triangle has two equal sides, then across from those equal sides, it has equal angles. So we do know that these two angles are congruent. That's angle DBC and angle ECB. So we have SAS. Moving along. Okay, measure of angle D is x. Measure of angle DAB is 5x minus 30. Angle DBA is 3x minus 60. And AB is 6y minus 8. And BC is 4y minus 2. The diagram's a bit small, so this is getting a little hard to see. We also were told that AB is congruent to BC. So I am going to make sure I mark that BC and BA are congruent to each other. So first I'm going to start on the angles. So we know that all three angles of a triangle add up to 180. So I can make an equation that says if I add all three of the angles of triangle DAB together, we make 180. So combining my like terms really quickly, adding 90 to both sides, we get our x value. X is equal to 30. So that answers the first question. Measure of angle D is 30. So I'm going to erase the x, and I'm going to replace it with 30 degrees. Now I can plug in, and I can find DAB, which is the second question. So that was 5x minus 30. 5 times 30 is 150. Minus 30 is 120. And now I can plug in here, or I can use the fact that all three angles of a triangle add to 180 to see that the last angle has to be 30 as well. So I see that this triangle DAB has two equal angles. That means across from those equal angles, it has equal sides. So I'm just marking that so we can know that for later. Next, it's asking me to find the length of BC, which is the side of the triangle. I already know in triangle ABC it has two equal sides. So I can make an equation where I set the two side lengths equal to each other, and then I can solve for y. So that is 2y is equal to 6, so y is equal to 3. Now if I plug in, 4 times 3 is 12, minus 2 is 10. And since this triangle has two equal sides, that means this side over here is also 10. And if I fill in some more angle measurements, this is 120. That means the angle next to it has to be 60. In triangle ABC, since it has two equal sides, it also has two equal angles. And if these two angles are 60, that means the last angle needs to be 60 as well to make 180. So I actually see this triangle as equilateral. So not only is this side 10, but this side's 10 and this side's 10. And guess what? This was an isosceles triangle with two equal angles and two equal sides. We already talked about the two equal sides. So if this side's 10, this side's also 10. So that makes BC 10 and DC 10 plus 10, which is 20. Okay, we are told here that AB is congruent to AC. Across from the congruent sides are congruent angles. So to find these two angles, I know all angles of a triangle add to 180. So 180 minus 50 is 130. Then since these angles are both equal, let me divide that by 2, and that gives me 65 degrees for each of these. In this triangle, it tells us that AB is congruent to BD. So across from my equal sides are my equal angles. So if this one's 55, this one's also 55. So together, 55 plus 55, that is 110. And that makes the last angle here 70 degrees. We're looking for angle CBD. So if I add the 65 degrees and the 70 degrees, I get 135 degrees, which is the measurement of that angle. Okay, so for the proofs, I'm not going to write up every single proof, but I'm going to talk about exactly what needs to go in it, statements and reasons. So when you're given information, I know RS is being bisected, that means it's being cut equally in half. TV is also being bisected, so it's being cut equally in half into two congruent parts. We also have these vertical angles over here. So now we can say the triangles are congruent by SAS. And once we know the triangles are congruent, we can use Cpctc to say angle T is congruent to angle V. And that's important because since we're proving the lines parallel, showing that alternate interior angles are congruent is one way of proving lines parallel. And these two angles, T and V, are alternate interior angles inside the lines on different sides of the transversal. So exactly what we do in your proof after your givens, you do need to mention Tx is congruent to xv and Rx is congruent to xs. And the reason for that is a bisector split the line segment into two congruent parts. Then you need to mention angle TXR is congruent to angle SXV. And the reason for that is that intersecting lines form congruent vertical angles. Then you can say triangle TRX is congruent to triangle VSX by SAS. Then we can say angle T is congruent to angle V by Cpctc. And then finally, we can say that TR is parallel to SV because if we have congruent alternate interior angles, that makes the lines parallel. Moving on, DA is perpendicular to AB. That means they form a right angle. CB is perpendicular to BA. They form a right angle. And AD is congruent to CB. My goal is to prove that AC, which is on this triangle, is congruent to BD, which is on this triangle. This is really hard to see right now because the triangles are overlapping. So I'm just going to go ahead and really quickly draw them separately. Remember, that's a great strategy for working with overlapping triangles. Take the triangles and draw them separately. And now I can clearly see that they share side AB. AB here, AB here. And if you look at the original diagram, AB is shared. It's where they overlap. Overlapping triangles always have something that's shared. So drawing the triangle separately allows you to better see that. So we have triangle DAB congruent to triangle CBA by SAS. And then we can say that AC is congruent to BD by Cpctc. So in your proof, what you would need after your givens is you need to say angle DAB and angle CBA are right angles. Your reason for that is perpendicular lines form right angles. Then you need to say that angle DAB is congruent to angle CBA. And your reason for that is all right angles are congruent. Then you can say AB is congruent to AB, and that's by the reflexive property. Then triangle DAB is congruent to triangle CBA by SAS. And then finally, AC is congruent to BD by Cpctc. Moving along. Okay, in this next one over here, we have AB is congruent to CD. Angle A is congruent to angle D. And our goal is to prove that BD, which is right over here, is congruent to AC. Oh, sorry, let me re-highlight that. BD and AC. So once again, I have overlapping triangles, so I'm just going to go ahead and draw them separately. BAD, CDA. Here are congruent sides from the givens. Here's our congruent angles from the givens. Share side AD. So AD is congruent to itself by reflexive property. Once again, we have the triangles congruent to SAS. And then we can say that BD is congruent to AC by Cpctc. So in your proof, after your givens, there's only one more thing before the SAS. AD is congruent to AD by reflexive property. Then you can say triangle BAD is congruent to triangle CDA by SAS. And then finally, BD is congruent to AC by Cpctc. Okay, last proof over here. So we have AB perpendicular to BC. We have DE perpendicular to EF. We know BC is parallel to FE. I'm going to stop right there. I'm going to highlight my parallel lines and the transversal that intersects them. I see my letter Z. I see my alternate interior angles. Okay, and I'm also told that AB is congruent to DE. So I can see that I'm going to be proving my triangles congruent by AAS. And then after I prove them congruent, I can say that AC is congruent to FD by Cpctc. Now, in your proof, after your givens, you need to state angle ABC and angle DEF are right angles. Your reason for that is perpendicular lines form right angles. Then you need to say angle ABC is congruent to angle DEF. And your reason for that is all right angles are congruent. Then you need to say angle BCF is congruent to angle EFD. And your reason for that is parallel lines transversal create congruent alternate interior angles. And then you can say triangle ABC is congruent to triangle DEF by by AAS. And then finally, say that AC is congruent to FT by Cpctc. I'm not going to do number 15, but I'm going to talk about how you would do it. So when you have a grid and you have coordinates, the best way that your triangles are congruent is SSS. You can use the distance formula to show that all the pairs of corresponding sides are congruent. So to show that RS is congruent to CD, to show that ST is congruent to DE, and to show that RT is congruent to CE. So basically, you would find the lengths of all three sides of this triangle and show that they are the same as the lengths of all three sides of this triangle. It gets a little tricky when we're talking about angles with coordinate geometry. With right angles, we have a formula we can use. We can do slopes and find opposite reciprocal slopes to show that we have right angles. But when it's other angles other than right angles, we don't really have a formula that we could use to figure that out. So in coordinate geometry, unless you're dealing with right angles, it's best to stick with sides because distance formula can show you what you need to know about the sides, and it makes life a little bit easier.